So before we get started with the main topic of this video, I want to review something that you all learned in chemistry, and that is the atom. Remember what the atom looks like. The atom has a nucleus, and inside the nucleus, we have several particles. We have protons, which are small particles that have a positive charge, and we also have neutrons, which are particles that are neutral. They have no charge at all. And remember, hovering around the nucleus are electrons. And remember, you can think of electrons as orbiting the nucleus, much like planets orbit our sun. So that's a general picture of the atom. Now, let us discuss the charge interactions between the particles that make up the atom. Imagine that I had two balloons. One balloon was positive, and the other balloon had an overall negative charge. And I placed these two balloons next to each other. If I release these balloons from my hand, what is going to happen? Remember, we discussed that since these balloons have opposite charges, remember, they're going to be attracted to one another. In other words, they're going to be drawn to each other because that's what opposite charges do. Opposite charges attract. And let's say that I have two balloons, but now, in this case, one balloon is positive and the other balloon is also positive. Well, what will happen here? Since these are like charges, remember, they're going to repel from one another. The same thing would happen if I had two balloons next to each other and one balloon had an overall negative charge and the other balloon also had an overall negative charge. These two balloons will also repel each other. And remember, if we want to know the magnitude of this force, or the magnitude of the force that exists between the two balloons, that is quantified by Coulomb's law, which says that if you know the charge on the first balloon times the charge on the second balloon, multiplied by Coulomb's constant K, and divide all of that by the distance between the two balloons squared, then you can mathematically calculate the magnitude of the force that exists between the two balloons. So now that we have reviewed those concepts, let us move on to introducing some new terms that you all need to be familiar with. Let us start with conductor. What are conductors? Well, if you have a piece of material and that material is said to be a conductor, what that means is it means that the outer electrons on the surface of that material are free to move around. So they're moving chaotically and moving all over the place. That's different compared to materials that are insulators. If a material is said to be an insulator, what that means is that the electrons, they are not free to wander around the material. They're not free to move around. For the most part, they are bound to the nucleus of the atom. And of course, we also have materials that behave as semiconductors, which means that they can sometimes be a conductor or that they can sometimes be an insulator depending on certain conditions. So now let us move on to the main topic of the video, and that is the creation of electrical circuits. How do you create an electrical circuit? Well, imagine here that I have a battery, and this battery here has both a negative end and a positive end. And imagine that I connect a copper wire to the ends of this battery. So this material in red here, this is copper. And copper is an excellent example of a conductor, which means the electrons that make up the copper wire and the electrons inside the wire, those electrons are free to move around. So since this end is negative, remember, according to Coulomb's law, those electrons are going to be repelled by the negative end, and they are going to be drawn toward the positive end. So thanks to these charges and also chemicals in the battery, those electrons are going to circulate around the copper wire, and that's going to look something like this. They're going to move away from the negative end toward the positive end. And so that is what a circuit looks like. In closing this video, let us move on to talking about the requirements to maintain charge flow across an electrical circuit. And there are at least two requirements. One, an external energy supply, such as a battery, to pump the charge through the internal circuit and establish a potential difference across the circuit. So that's the first requirement. And the second requirement says the external circuit must make up a closed conducting loop between the positive and the negative terminals. So with that said, let us move down to these four examples here. So I want you guys to look at these four examples, and I want you to determine whether or not electrons will flow across the circuit. We're going to do the first one together. So look at this picture here. Notice here how we have a copper wire in black, and the ends of this copper wire are connected to this positive and negative terminals of the battery. And also notice we have a light bulb here that is connected to this end of the copper wire, and we also have a switch. So notice this switch, you can either take this switch and you can close it or you can open it. Now notice the diagram here is showing us that the switch is open. So guys, you tell me, if this switch is open, will electrons flow through this circuit? Yes or no? Well, the obvious answer should be no, because if you notice, the second requirement is not met. There is not a closed conducting loop. Because of this switch here, this circuit is open. It's an open loop. Now, if we were to close this switch, then that would create a closed loop, and therefore the electrons will flow from the negative end through the light bulb toward the positive end. Okay? So guys, go ahead and look at the three remaining examples and determine whether or not we're going to have charge flow and decide on the explanation why or why not. So go ahead and pause this video and look at that really quickly, and then play the video in order to see the answers. Okay, now that you had an opportunity to think about it, here are the answers. So if you look at this diagram here, the explanation is no, there will not be any charge flow. And that should be obvious because requirement 2 is not met. There is not a closed conducting loop between the positive and negative terminals. Notice both ends of the copper wire are connected to the negative terminal. So of course, there is not going to be a flow of electrons. Here, there will be a charge flow, because if you notice, this end of the copper wire is connected to the negative terminal, and that end of the copper wire is connected to the positive terminal, and it's also touching the light bulb. So requirement 2 and 1 is met. So therefore, the electrons will flow from the negative end through the bulb toward the positive end of the battery. And of course, it will just keep flowing. So that is yes. And of course, the answer to this is no, because if you notice, this end is touching the negative end, and that end is also touching the negative end. So there's not going to be a closed conducting loop. Now, if we was to take this battery up here at the top, and we were to flip it, if we were to flip that battery, that would create a closed conducting loop between the positive and the negative end. But for now, there will be no charge flow. Okay, everyone, so before I stop this video, I just want to remind you all, if y'all have any questions involving our introduction to electrical circuits, please don't hesitate to contact myself or anyone else in the physics department. Have a good week, and goodbye.